Hello, morning. So welcome to today's video. This video, if you're watching it, this is a deep dive video following the prior knowledge check for Unit 1. So if you've had a go at the prior knowledge check for Unit 1 and you found some of it a little bit difficult, this is the first deep dive video that you can do to follow that. And this one is on types of number, as in different types of number that you will meet during this course. So it's very factual based. There's not loads to it, but I'm just going to generally introduce you to the different types of number that you will see throughout Unit 1, well, throughout the whole of the course, really. Okay, so I'm going to flip over now and I will see you soon. Okay, so as I said, this video is largely about just understanding some terminology, really. So I'm going to start off with the word integers, okay? Integer. Okay, and this refers to a positive, well, not a positive, it just refers to a whole number. So I'll put that down here, whole number. Okay, these can be positive or they can be negative. They can even include 0, actually. So if I was just going to write down some integers for you, I might as well just go from one point to another. If I said -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, all of these count as integers, okay? And the pattern would continue. We could have -6, -7, -8. We could have 6, 7, 8. It doesn't even have to be symmetrical. So these are the numbers that are referred to as integers. So what I'm going to do now is I'm just going to write down a collection of numbers, and I want you to see if you can identify the number which isn't an integer. So identify the non-integer. Okay, so I'm going to write down some numbers. Let's have 6, let's have 10, let's have 3.4, let's have 17, -8, 12, and -10. Okay, so I'll leave you to have a look at those and see if you can identify the non-integer. Give you a little bit of time. Okay, hopefully you spotted that the non-integer was 3.4. The reason why that's not an integer is because it is not a whole number, okay? So here we go, here are the integers again. Integers are whole numbers. The rest of these numbers were whole. Some were negative, some were positive. Generally, we don't bother putting the positive sign in front of a positive number. We just assume that any number that's written down is positive by identifying the numbers that are negative by putting a negative sign in front. Okay, that's the first section for integers. Okay, second one is we're going to look at decimals. Okay, decimals. Okay, so you'll be familiar with decimals from when we think about things in pound and pence. Okay, so for example, if I said something was £9.64, okay, the 64 part is the decimal, okay, because it recurs after this thing here, which we call the decimal point. Okay, and that is what splits numbers between whole numbers and part numbers. Okay, so when we look at this 64 pence, we know that that's not quite enough to make up a pound, so the decimal number is not a whole number yet. Okay, it hasn't yet progressed to being whole. We wouldn't, in a way, I shouldn't have used this as an example, because we wouldn't actually read the decimal number as 64, we would read it as 64. Okay, it's just in the terms of pounds and pence, we've used it in this way. So for example, if I had a number which was 3.2591, okay, we would call this number 3.2591, okay? Because this has ended, okay, this here is what's known as a terminating decimal. Okay, so terminating decimals refer to decimals with a natural end. So decimals with a natural end. Okay, right, so other examples of terminating decimals could be 4.21, 7.3, we could have 8.2, we could have 0.0005, okay? All of these are terminating because I'm able to write them down, okay? They've got a natural end and that's that. So we refer to them as terminating decimals. Okay, so that's one piece of knowledge. Okay, we then get things called recurring decimals. Okay, I'm going to put this down here. So you can see where I wrote 6.3 off the screen. Let's see if I can turn that. No, let's just rub that out. So the next thing that we get is recurring decimals. Okay, and recurring decimals, okay, these are decimals that go on forever, okay? So for example, you might have seen some, like, say for example, we've got 0.3 recurring occurs a lot, okay? So that would be 0.3, and the 3's just go on forever and ever and ever until you can no longer see them, okay? But just because you can no longer see them, it doesn't mean they've stopped, so they're still there, okay? Right, we've got a way of writing this, okay? We've got the way of writing down a recurring decimal, and what we do is we indicate a recurring decimal with a dot above the number that is recurring. So here we go, we'd go 0.3, and then we'd put a dot above that, which means that the 3's are going on forever. Okay, so that is a recurring decimal. Recurring decimals can also have a pattern. They could go like this, for example, 0.1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. I'm going to put dot, dot, dot here, okay? This would be a recurring decimal, okay? But it's got two parts. So if we were writing this with the notation, we'd write it as 0.12, and we put a dot over both parts. Now, if we had a pattern that was slightly longer, for example, let's have a look at if we had 0.152, 152, 152. Okay, we can see that the recurring pattern here is the 152. Now, in this case, we don't actually bother putting the dot above everything. We'd just go, we'd put the point here, and we'd go 1, 5, 2, and then we put a dot at the start and a dot at the end. And that's marking the start of the recurring pattern and the end of the recurring pattern. Okay, so I'll write another recurring pattern over here and see if you can have a think about how you might write that. So this time I'm going to have 3, 9, 6, 4. 3, 9, 6, 4, 3, 9, 6, 4. Okay, so have a stop and think about how you might write that down. I'll give you some time. Okay, so the way that we'd write this down is we'd write it down like this: 0.3964, and we'd put the dot over the 3 and the dot over the 4. Okay, great. So these are what we call recurring decimals. So they're not terminating decimals, because terminating decimals have a natural end. Recurring decimals continue forever with a pattern. Forever with a recurring pattern. oh, I put an M at the end, with a recurring pattern. So whether that just be the pattern's the same number over and over again, the pattern's the same number repeated, or the pattern's this number. Oh, just a thought, there's one other type of recurring decimal. I'm just going to move us over here for that. Okay, so the one other type is when we get something like 0.5222222222. And this is when it's the last number on its own that recurs. And we'd mark this off by going 0.52, and then we'd just put the dot over the number that recurs. Okay? So when there's the dot, when there's the dot at the front and the back, there's two dots, that shows that there's a pattern. When there's one dot, it means that that's the one number that recurs. So have a think, what do you reckon this would look like? 0.38 recurring. Have a think what that might look like if I was going to write that down. Okay, I'll give you some moments to think about it. Okay, great. So this would be 0.38888888888888, and you can pretend that I'm going on forever. Okay, perfect. So that is, we've done terminating decimals and recurring decimals. Now within decimals we also have, okay, I'm going to rewrite decimals up here. Okay. Within decimals, we also have a thing called irrational numbers. Okay. Okay, and irrational numbers are decimals that don't terminate, but they also don't recur. So irrational numbers are, let's say, numbers where the decimals don't end and don't have a pattern. Okay, for example, we could have, well, I'm going to write a very famous one down. If you know it, well done. I'm just going to, I don't know many of the digits to it, but there's one that goes like this. It goes 3.141592654, and then it continues on forever. Okay, you might, if you recognise this number, you might have heard about it. This number is what's known as pi. Okay, this is a symbol that we'll meet later in life in maths, but you might know it from there's a film called The Life of Pi. Actually, not very little to do with pi. It's just how he inspired his name. But I think there's been different groups of people that have thought that the numbers to pi have answers to the meaning of life, or this, that, the other. But because essentially these numbers, they won't stop ending. You divide, yeah. So whatever's happened here, the numbers never hit a pattern. Okay, so you keep dividing and dividing and dividing, or whatever, and there's never going to be another pattern. I could make up another irrational number. Another irrational number could be 6.2751396418729. Okay, and yeah, this is just an irrational number. It's just a number that has no end. I should probably check the spelling on irrational, because I do believe it might actually have two R's, but I can never remember. Yes, it does. Irrational numbers, sorry about that. So irrational numbers does have two R's. Irrational number, okay, and it's numbers where the decimals don't have an end and they don't have a pattern. Okay, right. Not necessarily in the decimal section, they can be in the other section, but complementing irrational numbers are rational numbers. Rational numbers. And these are just numbers that have their terminating decimals or integer numbers, okay? So I'll put that there. Terminating decimals or integers. Okay, there we go. So rational numbers are terminating decimals or integers. Right, okay, so we've covered decimals, we've covered integers. Right, okay. There's another type of number that we're going to come across a lot, and that is fractions, okay? So I'll write fraction here, okay? Fractions can often cause a lot of people problems, but fractions essentially when we write one number out of another. So for example, a fraction, if you look at a fraction will look at this, something like 2 over 3, or we could have 1 over 4, we could have 3 over 5, we could have 1 over 6, we could have an 7 over 10. Okay, these fractions are all relatively normal fractions, and essentially what they mean is if we've got 2/3, they're saying that we've got a pizza here, we've divided it into 3, and we have 2 of them. Okay, if we have 1/4, I'll just square this time. Okay, and 1/4 would be 1 of the 4. So if you have a quarter of something, you have 1/4 of it. Okay, incidentally, this line here means divide. So it means divide by 4. So this is saying we've got 2 lots of something divided by 3. This is saying we've got 1 lot of something divided by 4. Okay, here, let's have something that we can divide into 5. Let's just go for a rectangle. 1, 2, 3, 4, 5. So 3/5 would be 3 parts of this. Okay, so we've got 3/5, 3 parts of the rectangle. Next here, we've got 1/6. Okay, 1/6 again. Let's go for a circle this time. So there, here, 1/6, it's there. Okay, and lastly, 7/10. I'm going to go for a box this time, and I'm going to cut it in half this way. Sorry, it's not a very equal half. 1, 2, 3, 4, 5. Okay, so 7/10 would be 1, 2, 3, 4, 5, 6, 7. Okay, these are all proper fractions. Okay, because the top number is smaller than the bottom number. Okay, so proper fractions. Okay, and let's use the right words. So this is the numerator, this is the denominator. Okay, numerator, denominator. Okay, so here we have numerator, denominator, or we've got top and bottom. But obviously we should use the correct words, but every now and again we obviously will slip into using these two because they, I guess, more obviously describe what they are. So next one, so this is proper fractions, and this is, I'll write a description here. We'll say fractions where the numerator is smaller than the denominator. Okie dokie. Right, so that's that for proper fractions. Let's have a look at the reverse side of that, which is improper fractions. Okay, so I'll write them down here. So it's IM here, improper. Okay, I don't understand why it's IM, but there we go. improper fractions. And these are ones, okay, where the numerator, I'll write this down, fractions, where the numerator is larger than the denominator. Okay, so for example, if I said here I've got 5 over 2, okay? So what this is saying is, saying we've got 5 over 2, we've got 5 halves, we've got 5 over 2, okay? Just to put this into perspective, just to try to make sense of what this is, I could write this. This is the same as saying I've got 5 lots of a half, okay? I've got 5 lots of a half. I've got 5 over 2, okay? So we're saying I've got 5 halves. Just to draw this out, in other words, this is like saying I've got a half 5 times. Okay, here we go. So I've got 5 over 2. I've got 5 halves. I've got a half 5 times, okay? Now, if we look at that, we know, generally, that 2 halves make a whole, okay? So, if I've got here, this is 1 whole, this is another whole, and this is a half. So I could say that 5 over 2 is 2 and a half, okay? And this is what's called a mixed number, okay? So I'll put a line there to say that. Sorry, there's a lot of lines going on here. This is a mixed number fraction. Okay, so we've got the improper fraction, which is when the numerator is larger than the denominator. And then we've got a mixed number fraction, which is I'll put that here and I'll put a definition underneath. This is when we have a whole number and a proper fraction. Okay, right, let's have another go at looking at an improper fraction and seeing what that would be as a mixed number, okay? So this time, let's say I've got, actually, if I put that there, we can use that for guidance, okay? So let me write down here, let's say I've got, 7/5. Okay, so 7/5. So we could also write that as 7 lots of 1/5. Okay, I'm going to write that down below here as well. So that's 7/5. So that's 1/5 7 times. One, 2, 3, 4, 5, 6, 7. So that's 1/5 7 times. Okay, so let's see. We know that 5/5 make a whole, because if we think about back to our little rectangle that had been divided into 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. If we get 5/5, ka-ching, we can cash that for 1 whole. So 1, 2, 3, 4, 5. Okay, so I'm going to lump them together, and that's 1 whole. And then I can see here what we've got left is we've got 2/5 by itself. So we could say 7/5 is also 1 and 2/5. So we've got the improper fraction and we've got the mixed number fraction. Okay? Right, have a go at seeing if you can convert this improper fraction into a mixed number. Okay, so we've got 8/3. Okay, so have a think. I'll give you some 10 seconds on this. It might take you more, but yeah. Right. Okay, let's have a look. So as we can see, this is 8 lots of 1/3. Okay. And then, so we can say that this is 8 lots of a third. So I'm going to write down a third 8 times. And then I'm going to group them together in groups of 3 if I can. So I can see there's a group of 3 here, because 3/3 make a whole. And then here, there's a group of 3, because 3/3 make a whole. So we're left with, we can see that that's going to be, let me just shuffle over a little bit. We're going to have 2 wholes and 2/3. Okay, right. Okay, perfect. We've got one type of number left, but this number isn't going to take very long. They didn't actually mention this in the prior check. But the last type of number is percentage. Okay. Okay, and if you see a percentage, you'll recognise a percentage by this sign. So a percentage is just another number, yet again. We could have 60%, we could have 75%, we could have 4.3%, okay? We could have 12%, okay? We could have 19%, okay? And all the percentage means is, it's a specific number. Percentage is a value out of 100, okay? Percentage is a value out of 100, okay? And this is when I say out of 100, this is actually as if it was a fraction that we're just not writing as a fraction. So 60% actually means 60 out of 100, okay? 75% actually means 75 out of 100, okay? 4.3% would mean 4.3 out of 100, okay? And remember, this line here means divide, okay? So 60% would be 60 divided by 100, 75% would be 75 divided by 100, 4.3% would be 4.3 divided by 100, 12 out of 100, 19 out of 100. Right. There's a collection of topics based around converting fractions to decimals to percentages, but I'm not going to worry about that here because that's going to come up as an actual topic within the GCSE maths. So I'm going to leave that there for today. But well done, and thank you for joining in. I'm just going to turn around and say goodbye, and then we'll be done. Hey! Okay, so well done. Thank you very much for joining in with that. I hope it was helpful to you if you needed it. Yeah, well done. Just if you have some struggles with those numbers, it's not too important to remember all those definitions all the time, but it is good to know them because what will happen is as you go through the sessions, you will start hearing these terminologies and seeing these types of number over and over again. And so, although it's not necessarily to always know what they are, it's important that you become familiar and you can see where they're going, and it will just help you follow the course generally. But I will drop in notes about what they are as well, so that will be fine. Okay, well.